Hi everyone. Today we will be completing our notes on multiplying polynomials. I want to start with this warm-up, which is just using the distributive property and our properties of exponents. Let's go ahead and begin. So number 1a, 5 times a quantity x plus 6. We use the distributive property to multiply 5 times x and 5 times 6, and we get the expression 5x plus 30. 1b, we multiply negative 3y into both of the terms, y and negative 9. Negative 3y times y is negative 3y squared, and negative 3y times negative 9 is positive 27y. Number 2, our properties of exponents. Here we have our product rule, x to the 4th times x to the 6th. We have the same base, so we can simply add the powers. 4 plus 6 is equal to 10. 2b, we have our quotient rule. Well, numbers with numbers, variables with variables. 12 divided by 6 is equal to 2. And n to the 4th times n, or divided by n to the 7th. Remember our quotient rule, we can subtract the powers, so we get n to the negative 3rd. I want to write my answer only using positive exponents, so I can rewrite this as 2 over n to the positive 3rd. Remember that negative exponent is only attached to the n, so only the n moves to the denominator. All right, let's go ahead and practice multiplying a monomial and a polynomial. This is very similar to the distributive property. This one's like 1b. We're going to multiply 2y times the quantity 5y minus 9. 2 times 5 is 10, and y times y is y squared. 2 times negative 9 is negative 18, and y times 1, I guess, is y. So we have the expression 10y squared minus 18y. Number 2, we're going to multiply negative x squared into each of the terms of the polynomial. So negative x squared times x cubed is negative x to the 5th. Remember, we add those exponents. Negative x squared times positive 4x squared is negative 4x to the 4th. Negative x squared times negative 12x is positive 12x to the 3rd. And finally, negative x squared times 6 is negative 6x squared. All right, that's our answer. Number 3. 3m times the quantity m squared plus 4m minus 1. We're going to distribute 3m into each of the terms. 3m times m squared is 3m cubed. 3m times 4m is 12m squared. And 3m times negative 1 is negative 3m. Finally, 5t to the 4th, distributing into each of these terms. Again, numbers with numbers, variables with variables. 5 times 2 is 10. T to the 4th times t to the 3rd is t to the 7th. Add those exponents. 5 times negative 3 is negative 15. T to the 4th times t squared is t to the 6th. And finally, 5 times negative 9 is negative 45. T to the 4th. All right. So again, this is very similar to the distributive property. A lot of this should feel pretty familiar. It gets a little bit different from distributing when we are multiplying like a binomial by binomial, for example. We can use the distributive property to multiply each of these things, but we have to multiply every term in the first polynomial by every term in the second polynomial. Okay? So we're going to distribute this 3x into both 7x and negative 2. And then we're also going to distribute this negative 8 into 7x and negative 2. So let's go ahead and do that. So distributing the 3x into 7x and negative 2. We get 3 times 7x is 21. 3x times 7x is 21x squared. And 3x times negative 2 is negative 6x. Now we also have to distribute the negative 8 into the 7x and minus 2. So every term in the first polynomial gets multiplied by every term in the second polynomial. So negative 8 times 7x is negative 56x. Negative 8 times negative 2 is positive 16. Now we can simplify this expression here. I see a couple of like terms. When we simplify, we get 21x squared. Those x terms can be combined into negative 62x. And then our constant term plus 16. Nothing to combine there, so it gets tagged along for the ride. This process of distributing, at least for a binomial times a binomial, is often referred to as FOIL, which stands for first, outer, inner, last. If I were multiplying the binomial 4x minus 5 times the binomial 3x minus 8, I would multiply the first terms, then the outside terms, then the inside terms, and then the last terms in each of the binomials. So the first terms being 4x and 3x gives us 12x squared. The outside terms multiplying together, 4x times negative 8 is negative 32x. The product of the inside terms, negative 5 and 3x, is equal to negative 15x. And the product of negative 5 and negative 8, the last terms, gives us positive 40. First, outer, inner, last FOIL. Although it's simply the distributive property, it really only applies to multiplying a binomial times a binomial. More simply, just think about this as multiplying every term in the first polynomial as every term on the second polynomial. You're probably going to get real tired of me saying that by the end of these notes. All right, let's go ahead and try example 2. So multiply and simplify. So here we have a binomial times a binomial. So we can use the FOIL method. So multiplying every term in the first polynomial times every term in the second polynomial, we get p times p is p squared first. Outer, p times negative 2 is negative 2p. Inner, positive 7 times p, is positive 7p. And last 7 times negative 2 is negative 14. Combining like terms, we get p squared plus 5p minus 14. And that's our answer. 2b, here we have 3g minus 7 times the quantity 2g minus 1. So we're going to multiply every term in the first polynomial times every term in the second polynomial. Using FOIL, because we have a binomial times a binomial. 3g times 2g first is 6g squared. Outer, 3g times negative 1 is negative 3g. Inner, negative 7 times 2 is negative 14g. And last, negative 7 times negative 1 is positive 7. Combining like terms, we get 6g squared minus 17g plus 7. Okay, so this is like the distributive property. Some students prefer to see a visual option, and I like to call this the box method or the table method. So we can set up a table. So using example 2b, I notice we have a binomial which has 2 terms and times another binomial which has 2 terms. So I'm going to set up a 2 by 2 table. Okay. On the column side, or on the left-hand side of my table, I'm going to put the terms of one of the binomials. On the top, I'm going to list the terms of the other binomial. And then just like how we would read a table, so rows and columns, we would line them up and see where they intersect and multiply where they intersect. So here we have 3g times 2g is equal to 6g squared. 2g times negative 7 is negative 14g. 3g times negative 1 is negative 3g. Negative 7 times negative 1 is positive 7. And I can actually just write 7 there. Okay? So be very careful when you're labeling your table. You want to keep those signs together. So this 7 minus 7, that's a negative 7 here. When simplifying, you can just take the sum of all of those boxes. So 6g squared plus negative 14g, or minus 14g, minus 3g, and plus 7. And you can see that once you combine like terms, you get the same answer as above. So either method is acceptable. If you prefer the distributive method, stick with that. If you prefer the box method, stick with that. All right, let's go ahead and multiply polynomials. I'm going to show you both methods for example 3. So here we have the quantity x plus 2 times the quantity x squared plus 5x plus 4. We're going to distribute a binomial into a trinomial. So multiplying every term in the first polynomial into every term of the second polynomial, we're going to multiply x by everything in the trinomial first. So x times x squared is x cubed, x times 5x is 5x squared, and x times 4 is 4x. Now we're going to multiply 2 by everything in the trinomial. So 2 times x squared is 2x squared, 2 times 5x is 10x, and 2 times 4 is 8. Now we've got a long polynomial that can be simplified. We're going to write this in standard form, so I'm going to go in decreasing power order. We'll start with x cubed. There's nothing to combine with it there. So that's just x cubed. X squared, we've got a 5x squared and a 2x squared. Adding those together, oops, I wrote G. We get 7x squared. Now our x terms, we have 4x and 10x gives us 14x. And finally, our constant term plus 8, nothing to combine with it there. That's our answer. Now, in some cases, I personally find the box method to be advantageous. I want to show you that in this example, example 3, how we would use the box method. So here we have a binomial, which has 2 terms, and a trinomial, which has 3 terms. So we're going to make a 2 by 3 grid. So here's our 2 by 3 table. So on the side with 2, I'm going to put the terms of my binomial, so x and positive 2. In the side with 3, I'm going to put the terms of my trinomial, so x squared, positive 5x, and positive 4. Now I can go ahead and multiply these together. So x times x squared is x cubed, 5x times x is 5x squared, 4 times x is 4x, 2 times x squared is 2x squared, 5x times 2 is 10x, and 4 times 2 is 8. One of the advantages of the box method is as long as these are written in standard form and we're not missing any of those terms, as like we go in decreasing power order, we're not missing any of those powers, then something interesting happens with these terms. So I noticed that some like terms, we have 5x squared and 2x squared. Other like terms, we have 10x and 4x. Interestingly, these diagonals are like terms. This isn't always going to be the case, but sometimes it happens that way. Be observant and see which terms are like terms, and then you can combine them. So simply we can write out our simplified answer in standard form, x cubed, and then our x squareds combine into 7x squared. Our x's combine into 14x, and then our constant plus 8. Okay, so you can see we get the same answer either way. You decide which method is easier for you. All right. At last, let's go ahead and try these on your own. Try numbers 1 through 4. Use either method that you prefer, and you can pause the video and then you can unpause to check your work. All right, go ahead. All right, here are the answers to numbers 1 through 4. Go ahead and check your work. Something interesting happens in number 2. I noticed that the middle, the inner and outer terms cancel out. This is a special case of multiplying called a difference of squares. W squared is a perfect square, and so is 25. So this is a difference, so a subtraction of perfect squares. For number 3, we didn't have any like terms, so when you did your multiplication, there was nothing to combine. And last, if your variable is t, I always like to put a little tail on my t just to distinguish from plus. All right? Did you get them all right? We're going to get a whole lot of practice on multiplying polynomials in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.